Okay, let's join the session. This is for the week 3. So you can stop me at any time if you have any doubts. I will again do some questions from the assignment, which is based on BJT. I hope you have watched the lectures, and these questions will be easy to solve. So let's start from the first one. Give me a second. So the question says for the circuit shown in figure 3.1, consider VBE on VBE on is equivalent to 0.6 volt. So can you just tell me what is VBE here? It's easy, right? The arrow points in the n direction. So this is P N. And this will be N. So this is NPN. So this makes this terminal as collector. This is emitter. This is base. So VBE is this voltage, right? So VBE on is zero point 0.6 volt. VCE sat means saturation, is 0.3 volt. Beta, beta is IC by IB. IC is collector current, IB is base current. It's given us as 150. Terminal voltage, that is VT, is 26 millivolt. Okay, and base current is 12 microamperes. So first question says, find the value of output DC voltage. Select the closest option from the following. So output DC voltage is V naught, right? 12 is the applied voltage and collector is your output. So the total voltage is at this V naught. Okay, so let's just write it. Find the value of DC voltage. So your ID is okay 6.06. Let me just check. IB is 12 microamperes. So your IC will be beta times IB, right? This means IC will be beta is 150 multiplied by 12 microamperes. This means IC is 1.8 milliampere. Now, what is V naught? Can I write the KVL? If I write the KVL from 12 volt to ground, it will be 12 minus the current flowing through here is collector current. IC times R, resistance, collector resistance, minus V naught is 0. I know IC, I know RC. I can calculate V naught as 12 minus IC, that is 1.8 milli, multiply RC is 3.3 kilo ohm. 3 and minus 3 will go. So V naught is 1.8 multiplied by 3.3, 5.94. which is exactly equal to what you have mentioned, 6.06 volt. So this is your V naught. So now the next question is, by calculating the transconductance, can you tell me what is transconductance? I output by I V input. We had studied in the previous session some formulas related to transconductance. Can you type in the chat box if you know? That's right. So do you know some another formula for calculating GM? This is correct, what you have said. This is output current by input voltage. This is absolutely correct. So what is, if I have to write output conductance? What will be the formula? Can you tell me the formula for output conductance? It will again be output current, right? So what will be the voltage? Which voltage for the output conductance? What will be the voltage? This will be voltage here, but which voltage? For transconductance, we need input voltage. For out for output conductance, we need output voltage. Okay, so here we need to calculate GM. We know collector current can be written as exponential of VB by VT. Now, if we differentiate it, actually this is transconductance. Delta, change in output current by change in input voltage. If the change is very small, then this is delta I by di by dV. So to calculate GM, I can write DIC by dVBE. Just differentiate it, you will get IS exponential of VBE by VT multiplied by 1 by VT. This is again IC. So GM will be IC by VT. So you can use this formula in BJTs to calculate GM. Just remember this formula. This is useful formula. So now my GM will be IC by VT. IC is we calculated. These questions are related, right? You need to use the previous values to calculate these quantities. So my GM is IC, that is 1.8 milliampere, divided by VT. VT is 26 millivolt. Milli and milli will cancel, so it will be 1.8 by 1T. Right? And GM is written in Siemens. Okay, so this is GM. So the question is, now find the amplitude of the signal current flowing through the collector terminal for a signal having 6.5 millivolt. So we need to calculate. We calculated. Okay, so we calculated GM. This is small signal voltage. So GM is, as you had mentioned in the chat box, IC by V in output current by input voltage. So V in is given. We need to calculate IC. So that will be GM times V in. I hope it is clear. This is the first formula which we wrote here. Okay, addition. So it will be IC by V in. Here IC is a small signal and V in is small signal. So GM is 1.8 by 20 multiply V in. The question says V in is 6.5 millivolt. So 6.5 millivolt. This comes out to be 1.8 multiplied by 6.5 divided by 90. This comes out to be 0.58. E option 450. Have you calculated it? I'm getting 0.8585 milliamp. So that is 585 microampere. One second. We need to check the values because this is 26 millivolt. It is KT by Q. K is 1.28 into 10. Let me just check. 10 is for minus 23 or 1.2 or 1.3. You need to check that value. But in electron volt, it is 8. One second. 8.65 into 10 is for minus 7 minus 5 divided by 1.6. This is electron again. Electron volt multiplied by temperature, which will be a room temperature, and you can calculate the value. 8.65 into 10 to the minus 5 electron volt, electron, and multiply it with temperature. Let's say we have room temperature of we have a temperature of 3, but this is in Kelvin, right? So you have to convert your degrees to Kelvin. So this will be 8.65 multiplied by let's say 300, and you have 10 to the minus 5. So this comes out to be around 26. So you can use this formula to calculate VT. Okay, so in the question, we had to calculate GL. So, one second. So there is something in my calculation. Okay, this is 26. So here we did wrong. Thanks for pointing this out. 1.8 divided by 26. Okay, multiply by 6.5. So this is exactly 450 microampere. Yes. Okay, so let's move to next question. Find the value of R pi of BJT. Select the closest option from the following. What is R pi? Can you tell me what is R pi? R pi is the input, yes. Input impedance That means R pi can be calculated as V in by I in, right? Right? So if I write it as, just remember these formulas. Input current is your IB, right? So if I write here IB and multiply in numerator as IC and denominator as IC, can you tell me what I can write for R pi now? IC by IB is beta, right? And what is IC by V in? You just did this in the previous question. What is IC by V in? Take a minute and you can write it in the chat box. What is IC by V in? No, option is okay. What is, I'm just asking what is IC by V in? So solving the questions is easy. You just you understand these terms. GM, right? GM means transconductance. So I can write beta by GM. So this is one formula to calculate R pi other than directly using voltage by current. So now can you calculate now R pi? Now the question R pi will be beta. So beta is 150 divided by GM. We just calculated GM. 1.8 by 26. So you can calculate R pi now as 150 divided by. Now it is around 2.166 kilo, right? So you can check again. Yes, option B. Option B is the correct answer. So this is how you can calculate R pi. Just remember these formulas. These are important for BJT. Okay, so the next part of this question is find the value of output signal. Okay, so now we need to find V naught, V output for V in of 3.25 millivolt. Select the closest option from the following. Can you give it a try? I will wait. Then I will show. Sure, sure. Give it some time. Remember that this is small signal. That means 12 volt will be grounded and your output resistance is 3.3 kilo ohm. And now your input signal is at 3.25 millivolt. Ignore the DC part. Just use the AC part. Just a hint, you can use GM from the previous question as I output by V input. Just give it a try. Okay, so I assume you tried it. So from GM, I can calculate I out as GMV in, and from the previous part, GM was 1.8 by 26 multiplied by 3.25 millivolt. So I can calculate I out as 1.8 multiplied by 3.25 divided by 26. So I out is 0.225 milliampere. Option A. Okay, let us check. So now V output will be simply, as I said here, the DC 12 volt will be grounded. So my V out will be simply IC, that is output current multiplied by 3.3 kilo ohm. It will be easier in the next questions when we will draw the equivalent circuit. So this is I output multiplied by 3.3 kilo ohm. That is 0.225 into 10 to the minus 3 multiplied by 3.3 into 10 to the minus 3. This and this will cancel. So it will be 3.3 multiplied by 0.225. This is 0.7425. You are correct. Okay, so this is now two more questions on BJT, which is a different circuit. This one is a different circuit. So what does the question say? For the circuit shown in figure, consider VBE on is 0.6 volt. Okay, can you tell me what is this terminal and this terminal? Let me just call it A and B. Can you tell me what is A and what is B? Which is collector and which is emitter? You should be able to know which one is NPN and which one is PNP, and then it will be easier to know which is emitter and collector terminal. Can you tell me for this figure which one is emitter and which one is collector? Just look at the arrow. I have always said that it's easier to know in this way. Arrow points from P to N, and here B is emitter, A is collector. Right. Just look here. PN. That means this one is P, A is N, B is N. Now, positive bias is connected to A. That means it is reverse biased. And collector is always reverse biased, collector base. So, above one has to be collector and B has to be emitter. Correct? So, now that means this terminal, in this terminal, voltage is given VBE zero point 0.6 volt, beta 200, thermal voltage of 26, and early voltage here is given. You know, early voltage is used to calculate output resistance, right? R naught is given as 1 by lambda I collector or VA by I collector. So this is how you calculate R naught. Here it is given that hint use the effect of R naught for the analysis. So we need to use this R naught. That's why VA is given. That is 100 volt. VB is such that DC current is IB is 10 microampere. Okay, so to find the value of base collector voltage gain, we need to find V output by VB, that is gain. Voltage gain V output by VB. We need to find this. Let me draw equivalent circuit. So it will be easier to understand. So we have three terminals. Let me first draw the base terminal. We have our base resistance. We have base to emitter resistance, and potential across this is VBE, and you call this resistance as R pi. Emitter, there is nothing connected to emitter, so this will be grounded. And this is your GM times VBE, and this is your R naught, and this is your collector resistance. Now this will be finally VR. How do you draw this circuit? So this is your circuit, right? So what you have to do is to draw the equivalent circuit or small signal circuit or AC circuit, AC equivalent circuit. What you have to do is just yes, we are replacing it by AC equivalent circuit. What you have to do is short the DC sources. That means at the ends you have to short them with the ground and then find the equivalent circuit. Like here, we have VB, that is AC input. So we have VB here, that is AC input. We need to use that, and DC is shorted. And at output, we have V output here. And now, when this DC bias is grounded, so what are we left with? Emitter ground, a resistor RC here with V out. That's what we have drawn here. V output, and we have collector distance. And this part, let me use different color. This is an intrinsic transistor, right? Where we have output resistance R0. GMVB is governs the current flowing through the transistor, and this is the R pi, which is input resistance. Now, what we are supposed to do is we need to calculate V naught by VB. So, if I do a nodal analysis at here, so what will be V current coming in will be equivalent to current going out, right? So I can write V naught by RC. RC, look here. These two components are in parallel, right? R naught is first terminal is V out terminal, and second terminal is ground. Similarly for RC as well. So these two are in parallel. So I can write RC parallel R naught plus GM VBE is equal to 0. So this is my KCL. So this means I can write V naught as Minus times GM, RC parallel R naught times VBE. So this is my V naught. Are you able to follow this? How I calculated V naught? Is this clear? So I can move ahead. If this is clear, then what we need to do is we need to calculate V naught by VBE, that is our base voltage, magnitude. So this will be GM times RC parallel R naught. So I need to calculate first R naught. Okay, so as I said here, R naught is VA by IC, beta is given. So let me just first calculate. R naught is VA by IC, that means VA is 100, beta, let me just first write it. Beta IB, beta is 200. And what was IB? IB is 10 microampere. 10 microampere. Okay, so this will be 100 divided by 2 into 3 zeros, and this will be 10 to the minus 3. So R naught will be 50 kilo ohm. I hope this is clear. Now R naught is 50 kilo ohm. What is RC parallel R naught? What is RC? RC is 3 kilo ohm, right? So this will be 3 multiplied by 50 divided by 3 plus 50. And this is K square. So will be K, 1K, 1K will go. So RC parallel R naught will be 3 multiplied by 50 divided by 53. You can calculate it. 3 multiplied by 50 divided by 53. So this is RC parallel R naught is around 2.83 kilo ohm. So now you can calculate V naught by VPE as GM. So again you need to calculate GM. I can use formula IC by VT times RC parallel R naught. So my V naught by VBE will be equal to IC, that is again 200 beta times IB into 10 is power minus 6 divided by VT, that is 26 milli into 2.83 kilo ohm. Okay, kilo and milli, this and this will cancel. So V naught by VBE will be, let's calculate it, 200 multiplied by 8 divided by 26. So this comes around 215.8. This is our gain. So what did you get? 0.28. No, you need to check. You may have missed some values, milli or kilo. Just check the values. Okay, this should be the answer. Okay, take it easy. So what next? Find the value of output voltage signal for V in 11 millivolts. So now my AC signal is 11 millivolt, right? So I need to find the output voltage. So here you can do one mistake. You just found out that VBE is 200. Let me just write 50. So this is what you found just calculated in the previous right here. Now V in is given as 11 millivolt. So is this V in equal to VBE? Let me just show you the circuit. This is your circuit. Check V in and you have VBE. Can you write V in place of VBE? Or you can check from this figure. This is V in and this is VBE. What will it do? Now V in is given as 11 point. How much was it? 11 millivolt. So what will be your VBE? Simple voltage divider, right? You have V in some base resistance and some intrinsic device resistance. So this is your VBE. So my VBE will be R pi divided by R pi plus RB times VA. Okay, so V out will be 215 multiplied by VBE, that is R pi divided by R pi plus R base multiplied by V in. We need to just calculate the magnitude, so this will be 11 milli. Can you tell me what will be V out? And for this, you need to calculate R pi as well. From the formula, let me just give you the formula. R pi is beta by GM. Can you try and let me know the value? Another formula we can use for R pi is VT by IB. This is another formula which you can use for R pi. VT is 26 millivolt and IB is given as 10 to 10 to the power minus 6 ampere. So R pi comes out to be 2.6 kilo ohm. And RB is also given in the question as 2.6 kilo ohm. So it is simply 2.6 kilo ohm and 2.6 kilo ohm. So this is simple, right? So my VBE will be simply V input by 2, right? So V output is 215 by multiplied by 11 milli by 2. So this is how you can calculate it. That comes out to 1 point, approximately 1.2 volt. This is how you can calculate V out from the formula. Okay, are there any questions till now? Because we are moving to few questions on MOSFET. Just remember those formulas for R pi, R naught, GM. Those formulas are important for solving the questions. Okay, so now we have few questions on MOSFET. From the circuit shown in figure 3.3, the values of the device parameters of the MOSFET are given by K, W by L. Just to give you an idea what we are talking about here. So if you have transistor here, this is NMOS or PMOS? This is PMOS, right? So ISD is mu P C ox W by L VSG minus VTHP into VSD minus VSD whole square by 2. So this is the formula for PMOS. And if in saturation, then ISD sat is equivalent to mu P C ox W by 2L VSG minus VTHP magnitude whole square. So this is the formula for the device in saturation, and this is normal operation in the linear region. So the first question says calculate the operating point VDSQ and IDSQ. If this is PMOS, that makes this terminal as source and this terminal as drain. So we have to calculate VSDQ. That means this is VDD minus V0. Okay, so this is what we have to calculate. All right. So if I assume device in saturation, I can write ISD. I can write ISD as 0.5 VSG minus VTHP whole square. Why did I get this 0.5 from? This is given in question KW by L. So let me just first write it with this KW by L. One second. KW by L. Well, so KW by L is mu PC ox. So K stands for mu PC ox. Just directly write the values. So my ISD will be 0.5 by 2 VSG. Okay, very bad. Right. Can you tell me what is VSG here for the circuit? This is V S. This is G term. We need to calculate VSG. Tell me what is VSG? Simple voltage divider, right? You have 20 kilo ohm. You have again 20 kilo ohm. You need to calculate VSG. So my VSG will be 20K divided by 20K plus 20K multiplied by voltage. That is, how much is that? 8 volt multiply 8. So this will be 8 by 2, 4 volt. So 4 minus VTHP is given as minus 1. So this will be 1 whole square. So this comes out to be 2.25, 2.25 milliampere. Okay, so now you have ISD. What you need to do is this ISD flows through the resistance of 2 kilo ohm. So now you can calculate V naught as ISD multiplied by 2 kilo ohm. So that is 2.25 milli, that is 10 to minus 3, multiplied by 2 into 10 is power 3. This and this will cancel. So this is 4.5, 4.5. So now VSDQ is from KVL. This is VDD minus V naught. 8 minus 4.5 volt, which is 3.5. So this is how you can calculate the what is Q? Q stands for QC. So we found out that current is 2.25. I will call this as ISDQ, 2.25 milliampere, and voltage is 3.5. So option D. Next question is small signal analysis. We need to calculate V output by V in. Assume that the coupling capacitor C1 is shorted for the input frequency. Can you draw the equivalent circuit for the MOSFET? Okay, let me just give you this. Let's say this is NMOS, this is drain, this is source, this is gate. Its equivalent circuit will be without channeling modulation. This will be its equivalent circuit, right? So now for the circuit given in this figure, I need to draw the equivalent circuit. I will just draw the circuit. You just let me know whether it is correct or not. So I have the input signal here. I have R gate 20 kilo ohm in parallel 20 kilo ohm. This is correct, right? So this is for the circuit given in this figure. Just remember that this is PMOS. The current is flowing from source to drain. So this is source. The current is I have shown in this direction. So if I use SG, sign reversal will be there. The current is flowing in the opposite direction. So just for the simplification for both using the same circuit for NMOS and PMOS, I'm using this equivalent circuit. So now can you tell me what will be V naught? So I will do again node analysis at this node. So this will be V output by 2K plus GMVGS equivalent to 0. So V naught by VGS. I can write as minus GM times. Okay. So now I need to calculate. Sorry, one more thing. V output is 2K multiplied by VGS. VGS is not exactly. So I can write it VGS, but in terms of V in, I need to write it in terms of V in. So this will be minus GM. Okay. What is VGS? A drop across 20K in parallel with 20K is 10K, and your RJ is 10K again. So this will be V input by 2. V input by 2. So I can write V input by 2. So then I can write gain as V output by V input as 2 and 2 cancel GM times 1K. I need to now calculate GM. Let me just write GM here in this space. So how can I calculate GM? I will use transistor current expression Kw by 2L VSG minus VTHP magnitude of step. So DISD by dVGS will give me GM. That makes it equivalent to Kw by L. VSG minus VTH, we just calculated it as VSG is 4, VTH is 9, so it will be 3. So that makes GM is zero point 0.5 multiplied by 3. So GM is 1, sorry, this is zero point 0.5 milli. So 1.5 millisiemens. So this is 1.5 milli into 1K, kilo into millimeter, so it will be 1.5. So this is your V naught by V in. I hope this is clear. Next is find the input resistance seen by the input signal source for the circuit shown. First, let me just give you an idea how we can calculate the resistance. In any circuit, how you can calculate the resistances in any circuit. Let's suppose you have this box of resistance R. You need to find its value. What you can do is, if you have ammeter and you have voltmeter, what you can do is you can connect these here, and you can connect voltmeter. You have battery. You know what is the voltage. Let's say you have voltage here, and now you calculate the current here. So what you need to do is you connect the supplies like this, and now you know the value of V and I, so you can directly use Ohm's law and write as V is equivalent to IR. So any resistance of this total box, which has R resistance, let's say, you can now know the value, which will be V by I. So that's what in the MOSFETs, if you have to calculate input resistance, output resistance, you can use the same technique as well. So the question says find the input resistance seen by the input signal source. So this is my circuit. I need to check this resistance. Okay. And while doing so, you need to short every other source. So that's the case. So I have here 10 kilo ohm and I apply a voltage of V Let's say current Vx and Ix, and I have the polar combination of 10 kilo ohm, and that's it. Then this grounded, then we have GM. Let's assume this is VI, GM VI, and we have VI. This is and this is. So check here. If I apply Vx here and you have Ix here, the current will flow here through this and go to ground. So my path is Vx is equivalent to Ix times 10k plus 10k. So my Vx by Ix will be my input resistance equivalent to 20 kilo ohm. So this is how you can calculate the resistances. Now what if I had to calculate resistance here or out? I will again do the same thing. This is my GMVI. This is my R out. Now let's call this simple R. And I'm attaching it with a voltage source Vx. So that means my Ix is equivalent to Vx by R plus GMVI. Okay. Now what? Now look here. When I said that when you calculate the resistances, you need to short the every other source. So now Vi will go to zero because your input signal will go to zero. So it will simply be Vx by R. That means your output resistance will be simple R. So the circuits can be complex, but you can use directly this. We will see in the next week or day or after that week how we can use this technique to calculate the resistance of the complex circuits. So for now, this is how you will calculate. Okay, last two questions for the session. For the circuit shown in figure 3.4, consider the values of the device parameters of transistors as beta is equal to 99, VB on is zero point 0.6, VC is at is zero point 0.3. Early voltage is again given. Okay, find the operating point VCEQ, ICEQ. So look at the circuit. This is what our circuit is. So again, this is NPN. This is collector, base, emitter. Okay. So my VCEQ, VCEQ will be the output minus emitter voltage. So we are interested in finding VCEQ, and ICEQ is the current flowing. This is ICQ plus IDQ, and this will be IDQ. So the current flowing through this terminal will be ICQ. We are interested in these two quantities. Okay, you have all the values. Let's see if we can calculate it. So I will apply KVL going in this direction, right? So can you help me with the KVL? You can type in the chat box. What will be the KVL? I will wait. Take your time and write a KVL from 12 volt to ground. From here to here. Write a KVL. If you are able to write the KVL, then it's easier for you to understand these type of questions. You can write in the chat box. If you need help, please let me know. Are you able to do it? Should I show? Okay, 12 minus zero point 0.6. 12 minus zero point 0.6, right? That is VBE and 2 times ICQ. Okay, let me just write here. So you have 12 as base voltage, then you have IC plus IB multiplied 1 kilo ohm, then you have IB times 97 kilo ohm, then minus zero point 0.6, that is your VBE, and at last 1 kilo ohm emitter resistance and emitter current 0. So you can write 12 minus zero point 0.6 is equal to IC plus IB is IE. So this would be 2K IE plus 97K IB, that is IC by IB beta. IC by beta. What we can do here, we can assume this as IE as IC. So I can write here. No, we can just directly write it as IC by alpha plus 97K IC by beta, that is 99. Now what is alpha? From the first of the sections, we know that alpha can be written in terms of beta as beta divided by beta plus 1. So this will be 90 by 100, so 0.99. So 11.4. You can type your value here in the chat box as well if you have found the answer. 11.4 is equivalent to, okay, sorry, one second. Okay, let me just check. So what you have written is 12 minus 0.6 is correct. Minus 2 ICQ minus 2 IBR, correct. Minus, you have missed one equation, that is, one second. Yes, yes, you are right. This is minus 2 ICQ minus 2 IBR, 2 times IBR because of IE is equivalent to IC plus IB. And we have used this for this term, right? 1 kilo ohm multiply IC. Yes. So this is correct, yes. You have written correct here. Nice. So let's move variable. If I take IC as common, multiply by 1K, so I get like 2 by alpha plus 97 by 18. Alpha is 0.99. So calculate this value, you will get IC of 3.8 million. So now when you have IC, again I will just quickly write the KVL. 1K IC plus IB plus. Now I'm writing the KVL for this branch directly. Just look here. This is 12 minus IC plus IB flowing for 1 kilo ohm, and then you have this voltage. This is VCEQ minus emitter times 1 kilo ohm, emitter current times 1 kilo ohm. So that's what we are writing here. And emitter current, as correctly mentioned in the chat box as well, this is IC plus IB. So I need to find VCEQ. This is 12 minus 2K times IC plus IB. Now all the values are known. VCEQ is 12 minus 2K 1 plus 1 by beta times IC. How? Because IB is IC by beta. Beta is 99, so this will be 100 by 99. 12 minus, that means just complete the value, 2000 multiply by 100, divided by 99. Is 2020 multiply IC. What was the value of IC? 3.8 million. Multiply by 3.8. So this is somewhere around 4.32 volts. You can do the calculation as well and find the values. Okay, I hope that was clear. Now for the circuit, we need to find R pi. So we know the formulas. R pi is beta by Gn. R pi is beta by Gm. Now let's use the values which we know. I can write Gm as IC by Vt. right? And what is IC by beta? IB. So formula for R pi I can use is VT by IB. Just remember these formulas. VT is thermal equivalent voltage, that is 26 millivolt, and IB is 3 point. IB will be IC by beta, so that is 3.8 milliampere by beta is 99. So this is multiplied by 99 million will go. So my R pi is 99 multiplied by 26 divided by 3.8. 677 ohm. So this is your R pi. Last question for the session is to calculate the intrinsic gain GMR naught. So we know GM GM is IC by VT, which we can calculate as 3.8 milliampere divided by 26 millivolt, millivolt cancel. 3.8 divided by 26 is 0.146 Siemens. This is your GM. Intrinsic gain is the transistor's gain. Let's say this is a R pi, this is a GM, this is VI, VI is here, GVI. This is intrinsic resistance, output resistance of the transistor. So when you have only this transistor, which has only intrinsic resistance, that is R naught, output resistance R naught. When you calculate the gain of this transistor, it is called as the intrinsic gain. So you just apply the KCL here at this node. You will find V naught by R naught plus GMVI is equal to 0, which will give you V naught by VI as minus NGM R naught. So this is called as intrinsic gain. When you connect the external resistor, if I have another resistor here, let's say R out, then the total gain is not called as the intrinsic gain because now R naught is in parallel with R output resistance, which is your external resistance. And without including the external resistance, the gain of the transistor you will get is called as intrinsic gain. Okay, so that's what we have shown here. That is GM R naught is V output by V input. Now we have calculated GM. We need to calculate R naught. R naught is early voltage by collector current. Early voltage is given in the question as 100 volt and collector current as 3.8 milli. So this comes out to be 100 divided by 3.8, 26 kilo ohm. 26 kilo ohm. So now GMR naught is 0.146 multiplied by 26 kilo ohm. And that is equivalent to 0.146 multiplied by 26. 3.796 K. So this is your intrinsic gain, which is very large, and it is close to this value. So E will be your answer. So I hope this was clear. So anything from the question which you again need to discuss on, feel free to ask. We have still some time left. If you have anything you want to discuss or you didn't understand, we can discuss it or anything in general if you have any questions. Yes, I will share the PPT and you have access to the folder. You can directly access this PPT from that folder. Check your email. In the email, you may have got a link of a public sheet, and that public sheet has the YouTube link and the PPT link, Drive, Google Drive link. Click on that Google Drive link. You will find the PPTs from week one, week two, and I will upload this week as well. If you have any doubt, you can just let me know right now, or we can close the meeting and meet next week. If you know, then thank you for joining as well and asking some questions. Okay, so let's, I guess, meet next week. Just do the assignments, and if you have any questions from this week, we can discuss in the next week and also discuss the rest of the questions for the next week as well. Okay, thank you for joining. We can, I guess, end the meeting. See you. Bhuvan, why actually we have just completed the session, joined very late. The session starts from 6 and it can hardly go to 8. At max, it will go to 8. So if you want to join the session, please join by 6. Same from the Friday, 6 to 8. Okay, let's meet next week. See you.